solve the equation. 5 over x squared minus 3x plus 2 minus 1 over x minus 2 is equal to 1 over 3x minus 3. So, the first thing we want to do is we want to be able to cancel out each of these denominators by multiplying the whole equation, both sides of the equation, by the LCD. So in order to find the LCD, we have to build it from these factors, right? From the factors of each of the denominators. So the first thing we should do is to rewrite this equation with each of the denominators factored out. So this equation becomes 5 over x minus 2 times x minus 1 over, so minus 1 over x minus 2, which stays the same, is equal to 1 over 3 times x minus 1, right? Because we can factor a 3 from each of the terms. So now, we want to build the LCD from each of the factors. So the LCD is going to be x minus 2 times x minus 1, x minus 2 we don't have to repeat, times 3 times x minus 1, which we don't have to repeat. So rewriting it, this is 3 times x minus 1 times x minus 2. That's the LCD. So now we want to multiply both sides of the equation by that same LCD. So let's do that. So 5 x minus 2 minus 1 x plus 2 is equal to 1 over 3 times x minus 1. And we want to multiply both sides by the LCD. So times 3x minus 1, x minus 2 on the right. And then this is going to be a bit of a squeeze, times 3x minus 1, x minus 2 on the left. So now what I'm going to do is I'm going to distribute that into both of the terms on the left side. And I'm just going to distribute. I'm going to worry about reducing later. So this is going to become 5 times 3 times x minus 1 times x minus 2 over that denominator minus 1 times 3 times x minus 1 times x minus 2 over x minus 2 is equal to 3 times x minus 1 x minus 2 over 3 times x minus 1. Great. So now that we've distributed the LCD into each of the terms, we can cancel out anything possible. So in the first term, there's an x minus 1 on the top and the bottom that we can factor out and cancel, as well as an x minus 2. Here there's an x minus 2, and here there's an x minus 1 and a 3. Let's not forget that 3. So what's left over? Here there's 5 times 3, which is 15, minus 3 times x minus 1 is equal to x minus 2, right? Awesome. So, continuing on, I'm going to distribute this whole negative 3 into this difference. So we get 15 minus 3x plus 3 is equal to x minus 2. So now we want to move everything with x to one side and everything that doesn't have an x to the other side, because we want to solve for x, right? So I'm going to do this all in one step. I'm going to add a 3x to both sides, and then I'm going to add a 2 to both sides, and I'm going to combine all of the numbers on one side and all of the terms with x on the other side. So on the right there's 15 plus 3 plus 2, that's 15 plus 5, which is 20. And then on the right side, you get x plus 3x, which is 4x. So 4x is equal to 20, which means that x has to be equal to 5. So now we have our answer, and since we're talking about rational expressions, there is the possibility that we could divide by 0, so we should check by plugging it into the original equation. So we want to check by plugging x equals 5 into this original equation, which is what we started with. Right? So, let's do that. So this becomes 5 over x squared, which is 5 squared, minus 3 times 5 plus 2. Right? All I did was just wherever I saw an x, I put in a 5. So continuing, 5 squared is 25, minus 15, that's positive 10, plus 2, that's 12, minus 1. Oops, and we wanted to put in a little question mark here. Sorry about that. Since we're checking to see whether it's true, we're not just asserting that it's true, we want to put a little question mark above the equal sign. And we want to check whether 5 over 12 minus 1/3 is equal to 1 over 15 minus 3, which is 12, right? Yep, it's 12. So, combining the two fractions on the left, what we want to do is multiply the top and the bottom of the second fraction by 4 so that we can get the common denominator of 12. So we have 5 over 12 minus 4 over 12. And we want to check to see if that's equal to 1 over 12. So combining, we just combine the top and put it under the common denominator. So 5 minus 4 is 1 over 12, which is equal to 1 over 12. So since this checks out, then our solution, x is equal to 5, is correct.